Okay, so the previous video got terminated abruptly. My system got crashed. So let me continue with the wherever I have stopped. Share my screen. Right. So what we were doing is we were varying the velocity and finding out what is the maximum height reached by the particle. That's what we were doing. And this is for the vertical motion, right? Okay. This is what we had seen. Now let us continue with the same procedure for 40 and 50 meter per second also, so that we get a consensus or we get a pattern relating Vy and H. What does it suggest? Okay, so now let me go back to my lab page. Right. So we had done it until 30. Now let me continue with the 40. Keep it at 40. And then I'm going to fire it once again. For the sake of continuity, refer to the previous video. So only then you will be able to get it. Now it is going above. You are not able to see that, but you can observe it here. 70, 71, 72, 75, 76, 77, 79, 80, 82, 83, 84, 88, 90. Wow. 97, 99, 100, cross 100. Okay. Good. 105, 107, 108, 111, 12, 14, 15, 16, 18, 19, 20, 21, 22. It's become slower. See? Takes a long time. 21. I didn't miss it. Okay, 122, I think. Okay, so 122 is the first one. Now let us take up the second one. Second one, it's continuing. It goes until 122. First trial we already recorded. 85, 100. Wow. 114. See, earlier from 0 to 100, it moves faster. But as it keeps on coming, 122, 122.5. I think 122.5 is the next one. Yes. Third reading. First reading, I think I just looked at it as 122. Second one was 122.5. Let us look at the third reading also. So, as the particle keeps on going higher and higher, you observe that the speed is becoming lower and lower. It takes a longer time, right? That's what we have seen, right? Okay. And one more thing that you observe here is that, see, this Vy is reducing 5, 4, 3, 2, 1, 122.5, 122.5. See, the moment it becomes 122.5, this becomes 0. Make a note of this. Okay, so we have taken 3 trials. So one trial, okay, let me write it down. So one trial was, I took it as 122, 122.5, 122.5. Okay, let me move on to the next one. Now what should I do? I should increase it to 50. Definitely, what do you think this time should happen? It should be not something like 122. It should be more than that, right? Cross 106. See, Vy here is around 15, 14. They should reach 0. Until it reaches 0, the particle keeps on going up, right? See, 4, 3, 2, 1. I missed it once again. Around 127, I think. 127. So this is what happens, reaction time. Okay, 127. So what I will do is write it here. I think, I don't know whether we have made a mistake or what, I'm not sure. because you see 5.1, 20.4, difference is 15. Difference is 15 when the velocity is doubled. Now, when the velocity is tripled, so here you see the difference is 5 and 40, 40 here. And here the difference is 5 and 122. I'm still not getting any pattern over here. It's around, so this I'm not getting any pattern. Now, if I look at this 15, if I look at this is 20 and 45, once again 15. Here also I should expect a 15. I think we had done some mistake in the previous one. Let me check it out. See, this is what you need to do. See, sometimes we might make a mistake, okay, while we do an experiment. And this will be consistent. Okay, when I look at the experiment, we will feel, yes, see, we have done it consistently. Definitely, we have not done anything wrong. But when you look at the readings, there's something wrong here, right? So according to this pattern, I should be able to observe this should be somewhere around, say 60 or 70, I should get it. 60 to 70, I should get it. Okay, when I find this anomaly, immediately what I should do is, I should recheck it. Let me recheck it for 40 once again, before I continue for the other trials. So make it 40 here. Made it 40, I made it 45. I got the previous answer as 122. Now let us see whether we get 122 now also, or do we get a much lesser value. And if I get a lesser value, it's good. We'll confirm that we have done something wrong and we have to redo it. Wow, see here, see here, see here. See, it is not even crossing 100 million. 81.6 something we got. Okay, I had made a mistake here while entering this. So let me enter it. So let me refire it once again at 40. 81.6 is the first reading. Now remember we are doing it for 40 meters per second. Okay, this is what will happen. So you have to be very careful while you do an experiment. And if you feel somewhere you have gone wrong, then redo it once again. Okay, that's the best way to get correct results. What did I say? 81, 81.8 something I said, right? 81. Sorry, 81.8. 81.6, I think here now. Once again. 81.8, 81.6. I'm not resetting everything. I am just trying to do directly here. Because the moment I see on fire, it resets automatically. So I'm not doing it. 81.8, 81.6. So 81.2, 81.6. Let us look at it more carefully. 81.63. Okay, 81.63. So now let us enter those readings. So these readings are incorrect. The whole reading is incorrect here. The first reading I got it as 81.2. Second one is 81.6. The third reading was 81.63. Now find the difference between these two. 45, 55, 65, 75, 80. Nearly 35 here. 35 here. Okay. Here, this is 20 and 45. Now I'm skeptical about this also. Let me verify this once again. For 30 also, let me verify. I'm not sure. Maybe you would have made a mistake. Let me verify everything once again. Okay, see, you can do mistakes. So that's what will happen. So 30, 90, everything is fine. Let me refire it once again. What is the answer you're getting for 30? You should get around 42 or something, right? 37, 38, 39, 40, 41, 42. Wow, look at this. 44, 45, 45.92, 45.92. That's what I got. Okay. So now let me check what is the answer that I have written there. 45.8. Okay, this is fine. These readings are exactly fine. So this reading, we got a difference over here. Okay. Now, maybe I'll check for 20 and 10 also. Why to take chances? 20 and 10. For 20, what is the answer I get? 20, let's cross 15, 18, 20, 20.4 nearly. No, let me redo it once again. I didn't notice it correctly. 15, 16, 17, 18, 19, 20, 20.41. Yes. Let me check it out for 10 also then. 20.41. For 10 it is, I know I missed it. Once again. No, it's not doing it. .07. Okay. .1 I have taken here, 20 point. Okay, so all these readings are fine. So now we do time paucity of time. I'll just mention this is 127, 127. So now we have got some readings over here. Let us understand what's happening. So as you see here, when the velocity is increasing, the height reached by the particle is increasing. When the velocity is increasing, height reached by the particle is increasing. The maximum height reached by the particle is increasing. So this goes hand on hand with our hypothesis. What's the next step? We need to take the average, right? We take the average and calculate what is the average. And then now in this experiment, I'm introducing you one more thing, which is nothing but graphical task. Okay. So we are going to plot a graph of the independent variable along the y-axis and the dependent variable along the x-axis. Now, what was my independent variable? Independent variable was your velocity. Velocity. So this is your velocity in meter per second. And this was your average height, okay, which you're going to plot it in the along the x-axis. Now, if you look at this, let us take the average of these values. So what are the average? Let me write it down one more table here to make it more clearer. So we have velocity and h mean. So velocity is 10, 20, 30, 40, 50. And h mean. First one is 5.1, second one is 5.1. What's the second one? Second one, let me find out what is the value of second one. Let me use my calculator. 20, 20.41, 20 plus 20.41 plus 20.41 divided by 3. I get this as 20.27. 20.27. I'll write it down here. 20.27. Once again, you see this is 5.1. Okay, I'll make it for only one significant digit. Let me make it as 20.3. Very, very important when you mention it here. Then third one, 45.8. 45.8 plus 45.1. 45.1 plus 45.91. 45.9 divided by 3, which should be 45.8 once again. This should be 45.8. Next one, 81.2. 81.2 plus 81.6. 81.6 plus 81.63 is equal to so much divided by 3 is 81.67. 81.67, I will make it as 81.7. And lastly, 127, I have taken it directly, 127. Okay, I've got 5 readings over here. Now I need to plot this. So let us take 10, 20, 30, 40, 50. Okay. Now you see this is 5, this is 127. Okay. And therefore, now let us say this is my 0. Now this 5 will be here. Now if I take equidistant 5, now what I need to do is this is the whole length I will get. So therefore, let me take this as 130, the maximum length. If this is 130, this should be 65, right? So the way how you have to divide your axis, 65. If this is 65, then maybe this could be 32.5, 32.5 or maybe 30, for example. If this is 30, then this could be 15 and this could be 5. Okay, roughly we have got something here. Now let us plot 10, 5 here, 20, it's 20.3, 20, it's 20.3, somewhere over here it should be 20.3, 30, 45.8, 30, 45.8, this is 40, 45.8, sorry, this is 30, 45.8, this is 65, 30, 45 would be somewhere over here. This would be around 47.5, 45.5 would be somewhere over here. This is the one. Then 40, 80.7, 40, 80.7, 40, it is 80.7, 80 would be somewhere over here. 80.7, 50, 127, 50, 127, somewhere over here. Maybe this is somewhere over here, and 50, 127 could be somewhere over here. So when I join all these points, what do I get? Do I get a straight line? I don't get a straight line, right? I get something like a curved path. Okay. Now, as we know, the relationship connecting V and H is nothing but V square is equal to U square plus 2AS, which I already learned. Okay, I'm not teaching the whole theory. I'm looking only at the experimental part. Okay, so 2 into, this is G into H. So therefore, V square should be proportional to H. So as you see, so H is like this. So this is nothing but your V square. But so this is your V. Okay, so this, if you plot a graph of V square and H, then definitely you will get a straight line. This is clear. So therefore, so see to it that, okay, now what kind of relationship does V and H have? Is it a straight line? It's not a straight line. It's a quadratic equation. Okay, or you can call this plot as a non-linear plot. Okay, so thus we have done an experiment to infer how does the maximum height differ or vary with the velocity of the throwing object, which is upwards. Okay, so thus we have got these two. Now at the beginning of the video, I had asked you about one of the independent variables that I am choosing here is nothing but your height. Now, what is my other independent variable? I hope you would have guessed it by now. The other independent variable could have been time also. Okay, when it reaches the maximum height, what is the total time taken? Okay, that also you could have used it. And thus you would have been related to, so as I increase my velocity, now for what time does the particle remain in air? You can ask it also, right? So if I say total time that the particle remains in air, which means the up time and the down time, both you have to calculate, which you call it as total time of flight. Okay, maybe you would have studied this related to your projectile motion. The same thing applies here also. Okay, so I am not looking at your syllabus and going along with it. So I'm looking at something which is related to syllabus, which has not been taught there, but still one can do an experiment. Okay, this is what I'm doing. Okay, guys, thank you for watching my video. So see you in the next video, okay, which would be related to something similar, but I'm thinking now to do with projectile motion. We'll start with projectile motion in the next video. Thank you. Like, share, comment, and subscribe to my channel to get more updates. Thank you.